Let's do some, ex- in fact, practice with each other about hermitian and unitary operators. Consider this example. Is measurement unitary operator or hermitian operator? Of course that measurement is not unitary, because unitary operators in fact preserve the norm of that vector. And when you measure, for example, a qubit in a two-dimensional Hilbert space that contains, for example, up and down, and the superposition that is plus, that is up plus down divided to the right, the square root of 2, you cannot measure the both at the same time. You measure only one, up or down. So measurement breaks the state into one eigenstate and change the norm of that state. So measurement is not unitary operators. Energy. When you measure energy of a system, can you measure imaginary numbers, complex numbers? No. You will obtain real numbers, and the real numbers that you measure in experiments and laboratories shows that measurement must be represented by, by a Hermitian operator. So we are getting closer and closer to the concepts of unitary and Hermitian operators that we need in next sessions. And also, when I want to use the example of, for example, qubit in measurement, you must know that qubit is the building block of quantum processing, quantum computing. Measurements are, in fact, things that lives in two-dimensional Hilbert space. And when we talk about up and down, and next sessions we'll see the blockosphere, it is the building block of quantum computing that is a two-dimensional, for example, Hilbert space that we are see in this example, that when you measure qubit, you obtain that in one special state, for example, up or down, not the both, and the superposition. Superposition is before measurement.